Hello, students. I'm going to explain questions in this book, Calculus and Vector for Nielsen School Textbook on Unit 7.5. Let's start. So Unit 7.5, before we start, review the formula. There's 2 and 3 formulas introduced here. So the first one is scalar projection formula. The second one is a vector projection formula. The third one is a direction angles formula. And I hope you remember them. Now let's do exercise. I'm going to explain to you a question on Unit 7.5, page 400 for question 14. Let's read it first. So you're given the vector OD for the vector here, and 3 points for A point, B point, and C point. Number 1, calculate the scalar projection for vector AB on vector OD. And number 2, verify with calculation the scalar projection vector AB on vector OD, add to the scalar of projection vector BC on vector OD. And these two, the sum should equal the scalar projection of vector AC and vector OD. Now for D, explain why this same result is also true for the corresponding vector projections. Well, this is a large question, so it has 3 parts to work on. Now I'm going to write it on paper to illustration to you. Now I wrote it on paper, page page 400. So for Unit 7.5, question 14. So vector OD is equal here. And given 3 points, I write down here, asking you for the vector AB on vector OD. OD is provided. AB, we need to do calculation. To find vector AB, we are going to take A point and B point. So, and point B minus point A. So we're going to write it in calculation. So if this is the vector components, so we're going to put B minus A. So 1 minus -2, the first point. And then for the Y, it will be 3 minus 1. And then for Z, will be 3 minus 4. Now we're going to get a point here. So it will be, change the integer. We're going to get 3, 2, and -1. That's vector AB. So by the way, so we're going to also do the vector BC. So since the question is asking, so for BC, we are going to write vector BC. So it's equal point C minus point B. So it's equal. So point C, -6 minus 1. And for Y will be 7 minus 3. And for Z will be 5 minus 3. Now we're going to write the vector BC. So we're going to get -7 and +4 and a 2. Now we are ready to do calculation. So since we got all the vector, now let's do the one for calculation, the scalar projection for vector AB on DC, on OD, excuse me, and divide the magnitude of OD. So we're going to take A. So A is 3. So 3 times -1. And then plus 2 times 2. And then plus -1 times 2. So we take the 2 vector times each point. X, Y, and Z, excuse me. Now we're going to divide the magnitude of OD. So we use a distant formula. So we're going to have a -1 square, add 2 square, add 2 square. So see what are we going to get? Use a calculator. So we're going to get the first one is a -3 and 4 minus 2. How about the magnitude? So we are going to get 1 and 4 and 4. And from the point here, so we're going to get, so that's -5 and 4, we get -1. And here is a 9. Square root of 9 is a 3. That's how we got the scalar projection for the vector AB to a vector OD on vector OD. Good. Now we are going to do the vector projection for the second part. Now for B, we continue to scalar projection on vector BC on vector OD. So I write the two vectors together. For vector BC, we already done the point calculation and got vector BC here. So, and then we apply the formula. Now we're going to dot these two vectors. So we have a -7 times -1 for X. So, and then add for Y is 4 times 2. And then add for Z, it will be 2 times 2. And we're going to divide the magnitude of OD, so which is -1 square, A2 square, A2 square. So we're going to get the answer here, excuse me, should be here. Now we're going to get +7 and then add 8 and then add 4. And the magnitude of OD, we already done it in the last question, is equal 3. So now we get the final answer. So it's going to be equal 19/3. That's how we do it. Now the next part. Now the next part here is going to be the scalar projection of vector AB on vector OD. So plus the vector BC on vector OD. So it's going to be equal the vector AC on vector OD. Now we done the first two in front. Now we're going to prove this side. So we already have the So to dot the product for AC, we have to find the vector AC. So we're going to use point C minus point A. So we're going to get the point here. So it will be -4, the first one. The second one is the 6 and a 1. So we're going to apply here to calculation for the scalar projection. So vector AC dot OD. So we're going to use -4 times -1 for OC. So, and then add 6 times 2 and add 1 times 2. So we're going to use a distance formula, find the magnitude of OD, which we done already, is equal 3. So we're going to write the final answer here. So it's equal. So what are we going to get? It's going to be equal 18/3, which is equal 6. So now we're going to use the formula here, the book asking you to prove. So we just going to write the left side. So OA is going to be 8, the first part. So I'm going to move my camera here. Now the final part. So the first one, the scalar projection answer is -1/3. So, and then add the second part is 19/3. Should be equal, the last part is 6. So we directly write the formula, the question asking to prove. So the first part is -1/3 at 19/3 is equal 6. Yes, it is. So when you combine, that's 18/3. So equals 6 and 6 equals 6. So we successfully prove like vector AP on OD, so it's -1/3 plus vector BC on vector OD, 19/3 is equal vector AC on vector OD. So left side equal right side. So we successfully complete the question. So when you do with detailed attention, it should be easily arrive the final correct answer. So let's continue, move on for the next part. So this is Marquis Learning Center, the tutoring class. This is our contact number, and this is the course we majoring tutoring. And we, when you like my video, the explanation of vector scalar projection calculation, so please subscribe my video. I will continue explain the same topic for vector. Thank you. Bye-bye.